Dr. Seth Shonkoff, Executive Director of Physicians, Scientists, and Engineers for Healthy Energy, and visiting scholar in the Department of Environmental Science, Policy, and Management at the University of California at Berkeley. He will set the stage for us and introduce David Hughes, respected geoscientist and the author of Drilling California, a reality check on the Monterey Shale. Following the 15-minute presentation, we will be taking your questions. To enter the queue, please identify yourself and your organization in the Q&A form at the bottom left of your screen. Now here to get us started is Dr. Seth Shonkoff.
Hello, good morning everyone. So I'm just going to give a brief overview and then I'm going to hand it off to Dave. So here we go. The Energy Information Agency and INTEC estimated that there are 15.4 billion barrels of technically recoverable oil in the Monterey Shale. The EIA then adjusted this estimate down slightly to 13.7 billion barrels last year. These optimistic EIA INTEC estimates are based on assumptions that the Monterey will prove to be as productive as the Bakken in North Dakota and the Eagle Ford in Texas, which produce more than 2/3 of U.S. tight oil. From these estimates sprung economic projections that the Monterey Shale would provide major economic and job opportunities for California. The University of Southern California and the Western States Petroleum Association both put out reports that estimated major economic opportunities for California. However, both the USC and the WSPA reports made assumptions that the Monterey Shale would be as or more productive than other shale oil plays, without any actual empirical data on the Monterey Shale to support that assertion. This report represents the first analysis to quantify actual oil production in the Monterey Formation and asks the question of whether these previously modeled studies based upon assumptions from other regions are accurate based upon real data. We use the Drilling Info database, which is widely used by industry and government in North America. Again, the results of this report are based on actual oil production data from the Monterey Formation, as opposed to only optimistic assumptions. It is clear from our data analysis that oil production from the Monterey is not likely to be the major economic opportunity that the EIA, INTEC, and USC studies have indicated. Instead, the data suggest that the Monterey is not analogous to other highly productive tight oil plays. And although it will certainly produce more oil and gas, it is not the bonanza that it has been characterized as. I will now pass it over to the report's author, David Hughes, to discuss the specifics of our analysis and its results. Thank you.
Well, thank you, Seth. Just a couple slides at the beginning to look at the history of oil production in California. California is a mature oil-producing region. There has been roughly a little over 230,000 wells drilled since 1977. And these two maps basically just indicate, the map on the right is the distribution of active wells. The map on the left is the distribution of inactive wells that have been shut down. So if we look at this chart, we can see that in fact California oil production peaked a little over 1 million barrels per day back in 1985. It's producing about half of that now from around 50,000 wells. So the average well in California produces about 10 barrels per day. If we look at the INTEC report that Seth referred to, the estimates were that the Monterey contain about 64% of all of the tight oil in the United States. This chart basically compares that to the big producers today, which are the Eagle Ford and the Bakken. The Intech report assumed that 1,700 square miles of Monterey Shale could be drilled at a density of about 16 wells per square mile, so that there was a total of about 28,000 locations, and each well would produce a little over half a million barrels of oil. If we look at the history of production of oil from the Monterey, we can see that it has produced a lot of oil. The Monterey has produced about 1 billion barrels of oil and 4 trillion cubic feet of gas since 1977. Most of that oil was produced from the Stevens Sand, which is a conventional subdivision of the Monterey. Some of these other units are producing from shale, but most are conventional reservoirs, so they're producing from fractured shale, which has permeability unlike tight oil plays like the Bakken or the Eagle Ford. This is the location map from the Intech report, basically showing the distribution of the potential play areas. And the orange are really the outline of Occidental leases. Occidental really holds most of the prospective land in the Monterey. A couple of cross sections through the Monterey and the San Joaquin Basin, basically just showing you how structurally complex the Monterey is and how variable it is compared to the flat-lying to gently dipping Bakken and Eagle Ford. So the Monterey can go from near surface to about 4 miles in depth over a distance of 40 miles or less. It's also much thicker than the Bakken and Eagle Ford plays, ranging up to 2,000 feet in thickness and more. As Seth mentioned, we used the Drilling Info database, and we looked at all of the wells that have been producing from the Monterey. There's upwards of 5,000 wells producing. Only about 2,500 of those are active. Most of those are producing from the Stevens Sand. However, this also shows a location of some key fields that we looked at that were referenced in the Intech and the USC study. This is a key figure from the Intech report, which shows the proposed or assumed production profiles from the Monterey Shale wells. The top figure is the so-called Elk Hills Area Shale vertical well, suggesting that the initial production over on the left-hand side will be about 800 barrels per day, and the average of horizontal wells will be about 500 barrels per day, and the average of vertical wells about 200 barrels per day. So we looked at all of the Monterey Shale wells that had penetrated or were producing from the shale part of the Monterey, not the Stevens Sand, and compared those to these assumptions. This first slide is a comparison of all of the Oxy wells drilled at Elk Hills. So this slide actually includes the Stevens Sand, and the three thresholds that I mentioned in the previous slide are indicated. The top one is the Elk Hills typical shale vertical well. We can see that only 4 wells in the last 6 or so years have actually exceeded that threshold. The average is 108 barrels oil equivalent per day and for directional wells and 96 barrels per day for vertical wells. So that's That's only about an eighth of the typical Elk Hills vertical well that was assumed, and it's only about half of the typical vertical well that was assumed in the INTEC report. We then looked at every Monterey Shale well in the San Joaquin Basin in this case, and we can see that only about 4 wells since 2007 have actually exceeded the highest threshold, the 800 barrel per day threshold. And again, sorry, I'm not looking at the right slide here. Yeah, so this is every shale well in the San Joaquin Valley, and we can see that there's 4 wells that actually exceeded the Monterey Shale only threshold of the INTEC report, and the average was less than a quarter of the upper threshold for directional wells, and only about an eighth of the upper threshold for vertical wells. This is cumulative oil production from all Monterey Shale wells in the San Joaquin Valley. So the older the wells are, the more likely they are to be close to the ultimate production of the well when they're finally shut down. But we can see that in the INTEC report, every well was assumed to produce 550,000 barrels of oil. And in the San Joaquin Basin, only 3 wells have actually achieved that threshold. The average production of wells over 10 years old is about 20% of that threshold, or roughly a quarter. Based on the INTEC report, which is extremely optimistic from our data analysis, the University of Southern California produced a study published last March, which suggested some rather large economic benefits from developing the Monterey Shale. They assumed that in their median estimate that by 2020, the Monterey Shale could increase employment in California by about 10%, so 2.8 million jobs. It could increase per capita GDP by 14%. It would provide $2.6 billion per year in tax revenue, so it would increase tax revenue by roughly 10%, and personal income by 10%. So these are rather extraordinary economic claims. If we look at the oil production assumptions that those were based on, we can see that there's a range of assumptions ranging from about a 30% increase in California production to as much as a 7-fold increase in California production from what it currently is. If you take an average of those projections, it amounts to about a tripling of California production. So fantastic increase in roughly 7 years. The USC study utilized a couple of fields that were discovered back in the mid-80s, but developed in the late 90s. And these are the Rose and North Shafter fields. An interesting feature of this is how localized these 2 particular fields are. They encompass about 20 square miles and were discovered by 3D seismic. The INTEC report, on the other hand, assumes that we can blanket drill 1,700 square miles at a density of 16 wells per square mile, and that's highly unlikely. Only small parts of those areas are prospective. Within those 2 fields, the U.S. study used 2 type wells. One of them was a discovery well, discovered back in 1983, and another was a well drilled in the mid-90s. And this is the production profile from these wells that they use to estimate the likely production from the Monterey for their report. If we look in detail using those type curves from those two fields, we can see first of all how much oil would have to be recovered. In the highest case, the most optimistic case, they're suggesting that 10 billion barrels of oil could be recovered by 2030. So that's about 2/3 of the total INTEC estimate. They suggested that amount of oil could be recovered from about 4,100 wells. I actually took the production profile and calculated how many wells you would actually need in order to recover that much oil by 2030. Then it works out to a little over 200,000. Even the INTEC study said that we only have 28,000 locations, so clearly those estimates are not possible in any way, shape, or form. The minimum estimate, which would recover 3 billion barrels of oil, and remember, the Monterey in the last 35 years has only recovered 1 billion barrels of oil, would still require twice as many wells as the INTEC report says are available in terms of locations. So I'm just going to leave it there and open it up for questions.
Great. So thank you, David. Thank you, Seth. We'll now be opening up the floor for questions. If you want to, for those of you joining us by phone, you can take yourself off mute by pressing *7. And now we'll open up the lines for questions. Please just identify your name and your organization.
Seth Nidever, Hanford Sentinel. Can you hear me?
Yep.
Sure, go ahead.
Yes.
Yeah, my question is, given what you're saying, and I hear similar things from the oil industry, why do you think there's so much hype? There's been so much hype surrounding this, surrounding the Monterey.
I think it all stems back to the INTEC report, which was published in mid 2011 by the EIA. Clearly the Monterey is a very important source rock. A lot of the fields in the San Joaquin Valley are charged with oil from the Monterey. The question is, it's structurally complex, and so it's fractured. So a lot of that oil is produced from migrated pools. So a lot of the oil is likely migrated out of the formation itself, unlike the Bakken and the Eagle Ford, which are really producing from source rocks or producing from, tight rocks immediately adjacent to those source rocks.
And just one follow-up question, if I may. Why do you think there hasn't been a similar enthusiasm for green energy, large-scale green energy development?
Well, I think that there is quite a bit of enthusiasm in California for large-scale green energy development. Probably not enough. When you look at the amount of non-large hydropower renewables in the world, right now it's less than 2% of total energy. So, there's issues with intermittent sources of renewable energy. Hydrocarbons are the easy, energy-dense way to go. And that's worked for the last century and a half. But counting on, hydrocarbon bonanzas that don't exist, like the Monterey, is a real mistake. And obviously, we need to ratchet up the green energy initiatives a lot going forward.
Thank you.
Any other questions? Okay, I mean, if we don't have any other questions, thank you for joining us. That's all the time we will be taking for today. If we didn't get to your question, or if you have any additional questions later, please refer to the press contact listed on the media advisory, and we'll be happy to take your questions offline. Thank you.
Thank you.